All right, here's the next problem we have. It says, if the volume of a cylinder with the piston at bottom center is 75 cubic inches and the piston displacement is 70 cubic inches, then the compression ratio is. Okay, so first we need to know what the equation is for compression ratio. So our compression ratio is equal to total volume divided by CCV. All right, so we have this image right here. It's describing the compression ratio. So what is total volume? Total volume is going to be the entire cylinder's volume, including the displacement. So we talked about that in the last video, which is here in blue. That's as the piston moves from top dead center from bottom dead center to top dead center. That distance is called the stroke. And the volume that stroke displaces is called the displacement. And that's what engines are, the number like on the engine is talking about the engine's displacement. Like we said in the last video with the Mustang 5.0, that's a 5-liter engine, meaning the engine will displace 5 liters. Okay, so as the engine displaces that volume and compresses it to be exploded in the compression stroke or exhaust as in the exhaust stroke, it's all going to be trapped in this CCV. This CCV is a volume right here on top of, it's like the top portion of the cylinder that has the fuel and air mixture that gets pressurized ready for explosion. So that's another volume. So the idea is if we can get high compression ratios, meaning, so let's just look at it one more time. So the total volume, meaning this right here, this red and blue volumes divided by only the red, the compression chamber volume. If we can make that high, we can get a lot of power out of our engine. There is a point of diminishing returns where you can increase your compression ratio higher, but you won't get any more power. But for the most part, that's the logic behind it. The higher compression ratio, the more power you'll get out of your engine. So also, just on a side note, we have fuel octane. So what is fuel octane? Fuel octane, we say it or we look at it on the fuel, at our fuel pump, but we may not actually understand what it is. But what fuel octane is the higher the octane, the hotter and the more pressure it can be under before it will explode. So if I look here, I have our common fuel, like this is the low grade fuel. It's 87 octane for your car. But the aviation gasoline or avgas is 100 octane. That means I can compress it much higher pressures and higher temperatures before it's going to explode. We don't want it to explode before it's supposed to explode. If I put in car fuel into an aircraft engine, because we're running such high compression ratios, it will explode before the spark plug goes off, and that would cause something called pre-ignition or detonation, which we don't want. Okay, perfect. So that being said, this problem is pretty simple if you understand the concept of what total volume is, what displacement is, and what the CCV is. So in this case, it gives us with the piston at bottom center. So if it's at the bottom center, that means it's down here. This volume at bottom center is the total volume. So the total volume is 75 inches cubed. And we know that the displacement, meaning this this volume here in blue, is 70 inches cubed. Therefore, if I know that, I know the CCV must be the difference of these two, right? So the CCV is going to be 15 inches cubed. So that was it. That's what you needed to understand for this problem to be simple as it is. And again, you do have to memorize this equation because it is not given. So finally, we just plug it in. CR, the compression ratio, is equal to 75 divided by 15. And that comes out to be 5. So our compression ratio is 5-to-1, meaning our total volume is 5 times as big as our combustion chamber volume.